As mentioned by me in the last discussion, you go to your hadoop.apache.org, the actual the original source to get the information about Hadoop. So according to this, if you look at closely, it's an open source software for reliable, scalable, distributed computing. For reliable, scalable, distributed computing. So Apache Hadoop is a reliable, scalable, distributed computing open source software. That is what Hadoop is. When I use a term called Hadoop, I implicitly mean both your HDFS and MapReduce. Of course, we have other things like yarn and all. We talk about those things later, but Hadoop implicitly means HDFS and MapReduce. You also can see here Hadoop distributed file system, a distributed file system that provides high throughput access to application data. And you go to the getting started, there you come across learn about. Then you can see here HDFS architecture. Hadoop distributed file system is a distributed file system designed to run on commodity hardware. This is the most interesting thing. On the commodity hardware. So your HDFS is actually being, no doubt it is a distributed file system, but it is been designed to run on commodity hardware. So what exactly we mean by this commodity hardware? Any idea, friends? What we mean by this commodity hardware?
Commodity hardware means which is inexpensive and readily available.
Oh, that's really very convincing to hear. You are absolutely right, Annapurna. Commodity hardware is something which is inexpensive hardware. Usually, when we talk about storage, because that is the most crucial thing to any organization. You take any corporate, the most crucial thing is the data storage. So you take your traditional warehouses or data stores in terms of your RDBMS. These are all being set up on enterprise class database servers. Enterprise class database servers, which are very, very expensive. You take any database setup, Oracle, MySQL, any database that is being used by the organization, you take the setup, they are going to set up this on enterprise class database servers. They are going to set up on that, which is very expensive in terms of software, even in terms of the hardware. But when it comes to HDFS, it is not demanding you to have, it is not demanding you to set up on expensive hardware. It is been designed to be set up on commodity hardware, inexpensive, readily available hardware. And it is not necessary that your hardware is, or the hardware must be homogeneous. Say you have 10 machines in the cluster, and all 10 machines need not have the same configuration exactly. Of course, all must be 64-bit, and on all machines you need to have the operating system being set up and readily usable to you. But it is not necessary that all needs to be exactly same. Necessarily need not be. Even if there is slight change in the hardware architectures and you get a new enriched hardware today, maybe you have set up your cluster a year back, but now when you go for a fresh hardware to scale up your cluster, I mean, your 10 node cluster, you are trying to make it 12 node or 14 node or 16 node, something like that. Then you are going to, you prefer always to get or to scale up your cluster with the latest hardware on, latest available. So even then there is no problem. Even then there is no problem. As you rightly said, your distributed file system is designed to run on commodity hardware. It's not going to demand the expensive database class servers to be used to set up your storage, that is your HDFS, your distributed file system. HDFS is highly, of course, they are saying very clearly, it has many similarities with existing distributed file systems. However, there are significant differences. HDFS is highly fault tolerant and is designed to be deployed on low cost hardware. What do you mean by highly fault tolerant? What do you mean by highly fault tolerant? What do you mean by highly fault tolerant? Or basically, what do you mean by fault tolerant? Any idea?
Even there is any fault in the computer, at least there is a minimum guarantee up to a level it works.
Yeah, I agree with you, but slightly with a change. Because when you are setting up a cluster with hundreds of nodes, you have a cluster now where you have, these are the uh, 5 nodes you have now as of today. This is what your cluster is, your Hadoop cluster specifically. Over a period of time, you are going to scale up this one. You make it 6, 7, 8. You keep increasing, and it may run into hundreds or even thousands. Because with Yahoo as of now, the Hadoop cluster is, I don't know the exact number, but it is around about it is 12,000 odd nodes cluster. It is an approximate figure. With Yahoo, we have a 12,000 live Hadoop cluster running. It is growing. Out of these 12,000, one node getting down for whatever the reason, one node getting down for whatever the reason is not an abnormal thing. Maybe hardware failure, something went wrong with the hard disk, something went wrong with the motherboard, because these are all the hardware components. Anything can happen any point of time. In spite of taking all the best measures, anything can happen any point of time. Now tell me, out of 12,000 nodes, live cluster running with Yahoo, one node down frequently, not the same node, different nodes down at different points of time. Because of that reason, your cluster is going to be unavailable, or
No,
cluster is not completely available. Does that make any sense?
it makes sense actually.
No, I mean, if one node is down, you are not able to use the cluster. You think that,
We can able to use the cluster,
right?
but maybe the performance speed maybe varies, but we can use the cluster.
You can use the cluster, but interesting thing here, I'll tell you, what purpose we are using these nodes. We are using these nodes to store the data which is sliced or chopped into uniform blocks, and these blocks are being stored on these nodes. That's what we discussed, right, in the last discussion about distributed file system. Same, we are chopping, like how we are using a file allocation table where your data is being stored in the uniform blocks. Your media is being divided into uniform blocks, and depending on the need for a particular file, your data is being stored using those blocks. Same when you come to your distributed file system, again, the storage present on multiple machines is being uniformly sliced into blocks depending on the requirement, what memory you need for storing a particular file. Your file is divided into uniform blocks and is being stored. Now imagine my file A, these two blocks, you look at this one, these two blocks and these two blocks and this particular block all belongs to file A. Please try to understand this one. Then you'll be able to understand very clearly. Now for your file A, I have my data present on node 1, 3 blocks, node 2, 2 blocks, and node 3, 1 block. This is a node number and these are the blocks. If I want to work with file A, I need all 3 nodes to be live. Then only I'll be able to access my file A. For any reason, if my node, second node is down, you think I'll be able to access my file A?
Yes.
I mean, I'll be able to access my file A completely. But if
Maybe up to
my node 2 is down, because totally my file A has 6 blocks and those 6 blocks are present. 3 are present on node 1, 2 are present on node 2 and 1 is present on node 3. For any reason, if my second node is down, it is not accessible, you think I'll be able to access my file A? No,
yes, you can
because
access, right?
how you can access? Because on second node, I have 2 blocks present, but that node is not available to me. How I can access the data present on second node?
Second node you may not access, but the
But
data in third node and first node you can access.
accessing data present in third node and first node will not make my complete file. Will not make my complete file. It will make my complete file only when I am able to access all the 6 blocks. Because in IT, you have only 2 things, either 0 or 100%. There is no such thing that ever exists in IT called 99.99%. This doesn't exist in IT. Either you have the complete file accessible or your file is not at all accessible. But we are under the situation now, out of 6 blocks, 4 are accessible to me, 2 are not accessible. Can I consider, okay, not a problem, I can work with this? No, not possible. Either the complete data needs to be accessible to you or no data is accessible to. That is also fine. If it is accessible, it should be accessible completely. But I cannot. So, in a cluster of 12,000 nodes, one node getting down is not an abnormal thing. Because of this reason, if the cluster is not usable to you, then it becomes meaningless. That is the reason why they developed the mechanism in such a way that your HDFS is highly fault tolerant. Highly fault tolerant, I mean, even in some odd situation, if the node is down, no problem, still the data is being made available. Please look at this diagram closely, friends, you understand. You definitely understand. And I'll also open, in the meantime, you look at this diagram, you'll be able to understand. Your data is sliced into uniform blocks and those blocks are stored on the nodes in such a way each block is replicated twice apart from the original. So each block is available 3 times on the cluster in such a way that even if any node is down, still that block is being made available on the other node. I hope you are getting my point. What I mean by fault tolerant. I'll talk about this one now. What I mean by fault tolerant. I'll discuss that. Give me a minute. You look at this one closely. Look at this clearly. There is a file by name foo which is being stored on my cluster with the block numbering 124. Okay, and I have 3 nodes here, and the replication factor is only 2. My block 1, 2 and 4 are also present on the other nodes. I advise you one thing: you put your fingers against one node on the screen. Whatever I am showing you on the screen now, you put your fingers against one node and check it out whether 1 to 4 are present or not. You close the first node and check 1 to 4 are available or not. Annapurna, you put
Yes,
your
Srinivas.
fingers against one node, any node of your choice, and check whether 1 to 4 are
Okay.
not available or not. Even 3, 5 also. Any node you close. 1 to 4 blocks belong to file foo and 3, 5 blocks belong to bar. Even for any reason one node is down, still the blocks, the data is available. That is what I
Yes.
mean by fault tolerant. Because your hardware failure is not an abnormal thing, it is an acceptable thing. It is an acceptable thing. We never know when a machine is going to fail. No one can even predict. Maybe I can have some assumptions, but they never work or they never match. But at the time of developing my framework, I should keep all these things in the mind. My framework should be so robust. And that's where they're telling in the very beginning itself. I think you noticed. You agree with me, Annapurna?
Yes, Srinivas. I understand.
So your data should be completely available or it should not be available at all. Now imagine my 12,000 node cluster, for the sake of one node down, if it is not usable, then my usage time of the cluster will be hardly few minutes in a day, because often and then, one or other node is down, then I rectify that one and put it back, then after a few hours again one more node is down, then my cluster is not usable to me. Or in the middle of processing, a particular data set which is of 100 TB, some node is down. Even during processing also your node can be down. Then you cannot stop processing. You cannot halt the things. You cannot make the cluster to be unavailable. Keeping all these things in the mind, just imagine what sort of plan they have in the mind at the time of developing this kind of framework. HDFS is highly fault tolerant and is designed to be deployed on low cost hardware. You know very well, when you are trying to deploy your data or store your data on low cost hardware, the failure chances are more bright. You agree with me? At least if it is expensive hardware, chances are there that the failure is bit less. But on the low cost hardware, chances are bright that failure is not an abnormal thing. That is the reason why you can see here, hardware failure is a normal rather than the exception. An HDFS instance may consist of hundreds of thousands of server machines, each storing part of the file system's data but not the complete file system. If it is centralized file system, your entire file system is present on one node. Your entire file system is present on one node. But in your HDFS, your file system is present on all the machines. That is what they are telling here. Each storing, because you have hundreds or thousands of server machines, each storing part of the file system's data but not the complete data. And you see, the fact that there are huge number of components and that each component has a non-trivial probability of failure means that some component of HDFS is always non-functional. Therefore, Detection of faults and quick automatic recovery from them is a core architectural goal of HDFS. Beautiful part. See how much care they might have taken. Of course, that is the reason why today it has become so popular. It has become the choice to every organization to leverage their data storage and quick processing, because they have taken such extreme care in making up your things. HDFS is a part of Apache Hadoop core project. HDFS is a part of Apache Hadoop core project. That's what I'm telling all the times. So you need to understand from this one, HDFS is no doubt a distributed file system, and I need not tell you what I mean by distributed file system by this time. A file system which is distributed across multiple machines. A file system distributed across multiple machines. Now, file system is no more centralized. You have your file system present, a part of the file system present on every node. You need to understand this terminology. You call sometimes this one as host, sometimes this one as a node, and all these put together we call it as a cluster or well coordinated systems to achieve a specific goal can also be called as a cluster. So this entire thing, I call it as a cluster. Please try to adopt to these terms, friends, so that it will be easy for you to follow the coming sessions. We call these as either hosts or servers or nodes, out of which few may be masters and slaves. Few other may be slaves. So your Hadoop runs on your entire Hadoop. When I use the term called Hadoop, I mean both your HDFS and MapReduce. Please remember that. When I say Hadoop and its ecosystem, all the components present on your Hadoop cluster. That is what I'm trying to show you here. Let me take you out there to make you to understand. Yes, this is what is your Hadoop ecosystem. At the very lowest level, we have data storage. As part of the data storage, we have HDFS. We also can have similar storage techniques from different vendors. Like say for example, from Amazon, we have simple storage service called S3, which is on AWS, Amazon Web Services. HBase is called Hadoop database for structured storage. NFS with Mapr, Cloud Store. You take any of these storage, all has got the same ground principles. They're not different. They have the same ground principles. You understand HDFS today, you will be able to work with any kind of distributed file system, which is, I've shown you already in the last discussion. Hadoop distributed file system is a parallel, fault tolerant, high throughput distributed file system. You can, once you understand, you can define in the way you want. You can define in your own words without changing the meaning. You can enrich it. You need not by heart the standard definitions. Your HDFS is a high fault tolerant and high throughput parallel distributed file system. And on the top of your data storage, you have something called data processing. That is the reason why the course is being designed in such a way. We must talk about storage, then we must talk about processing, then only we can talk about data access. So without me discussing about HDFS and MapReduce, I will not be able to discuss Pig, Hive, Scoop and all. And without discussing those things, I cannot talk about Flume, Oozie, Zookeeper and all. Without talking about those, I cannot talk anything about ClickView, Talendy, your Datamir, all these things, Pentaho or anything. So I think you understand how this Hadoop stack is. Hadoop ecosystem. This is what we call it to be Hadoop ecosystem. You have data storage at the very lowest, and on the top we have data processing, and on the top we have data access, then we have data management, and finally your data analytics. Please fix this. Of course, I'm going to share all these things with you. We have already kept the training material in the blog. You can access that any point of time. You can go through that. Time to time we keep adding more documents to the training material. You can access those things whenever you feel they are required to you. But all these are available or developed from the same source what I'm showing you here. This is the best documentation that anyone can follow. So I sincerely advise you, friends, please follow this documentation only all the times. And this is the best way. This is what I am doing for the last decade and a half. Because being a Java guy, started my career as a hardcore C programmer, then moved to Java. And all these years I'm in the same stream. I was able to mature my skill set time to time without depending on anyone, because I was able to quickly go through these kind of technical documents, so my updation becomes more easier and less expensive and less dependent. Please adopt this one. Maybe it takes time initially for you, friends. I definitely understand, but this is the best way. You go to hadoop.apache.org and start referring the documentation from this source only. Let any author write a book or release a document or do anything in the Hadoop space, directly or indirectly, all are going to be from the same source. Maybe they read this one and they simplify it and give it to you in a very simplified fashion. But ultimately, all the stuff that you see in any document is going to come from this one only. So that's where I advise you to go through this one and make sure that you. One second, friends, one second.
Okay. Okay, thank you. Yeah, that admin sent the wrong link. So half training போயிடுச்சா? He said recording is there. I say okay.
Yeah, sorry, friends. Actually, I mean, yeah. Thank you, Arun. Thank you. Wonderful. Sorry, friends.
Yeah, no problem.
Yeah, maybe slight confusion. I'll see to that it's going to be resolved. So we look at this one very closely. You understand that's where they mention here very clearly. HDFS is a part of your Apache Hadoop core project. And what are the assumptions and goals that they have kept? Hardware failure, which we have discussed very clearly now. Streaming data access, Applications that run on HDFS need streaming access to their data sets. They are not general purpose applications that typically run on general purpose file systems. So I need more throughput. It's not like, because I'm working with, if your data is limited data, I need not come long the way to Hadoop. I can happily get it done through my flat file system. Something beyond, I can get it done through my databases. And when I fail to handle my data uh, beyond the storage limits of databases and all, then I need to have a feasible solution. That's where I'm thinking it now. So I cannot presume, the general throughput. Throughput, I mean the volume of the data I'm able to read and process. That is what the throughput. The emphasis is on high throughput of data access rather than low latency of data access. The latency comes because of the limitation in the hardware. How this high throughput of data access is possible, we're going to see it very clearly, friends. Don't worry. I'm just trying to make you to understand how HDFS has been developed actually. How HDFS, with what assumptions and goals your HDFS has been developed. Large data sets, simple coherency model, moving computation is cheaper than moving data, absolutely. We talk about this one. Portability across heterogeneous hardware and software platforms. Beautiful part, you see. Portability across heterogeneous hardware. That is what I mentioned just before. It's not mandatory, because today you have set up your cluster with 10 nodes with some hardware configuration. Down the line, after 6 months, you want to scale up your cluster, adding another 5 nodes. It's not mandatory that you go back 1 year back and get the same hardware to scale up your cluster. No. Whatever is the best hardware that is available to you that day, that can be used to scale up your cluster. So it's not, so it can work even on heterogeneous hardware architectures. Of course, the minimum thing is all must be 64-bit hardware architectures. They can have difference by Intel, by AMD, by different vendors, no problem. Even if there is a change in the hardware architectures, that's fine. It's going to allow. And even if you have software architectures, difference in the software architectures, even then it's going to allow you. That's what it is saying very clearly without any second thought. Portability across heterogeneous hardware and software platforms. So what I advise you to do is, please go through these points at your comfort. I'm not asking you by the time we meet in the next session, you must go through these things. No, please go through these things so that you understand. And these are helpful to you, especially when you face the interviews. When you face the interviews, these are really helpful to you. I hope you got the points, friends, what I'm trying to share with you. So my intention of discussing all these is to give you the better understanding on what is HDFS. I'm not talking anything about Hadoop now. I'm not interested to talk anything about Hadoop as of now. I'm just trying to make you to understand you want to master what is the ultimate goal, what is the end goal of all these sessions. The end goal of all these sessions, you need to be thorough with Hadoop ecosystem. Hadoop ecosystem. You want to be strong with Hadoop ecosystem, right? Ecosystem, I mean core plus components built on core. Core and the components built on the top of core. That is what Hadoop ecosystem is. In order to master your entire Hadoop ecosystem, where you need to start basically? Where you need to start? You need to start with data storage. If you want to start with data storage, you must start with HDFS. That's the reason why we are talking about HDFS in detail. And once we are comfortable with HDFS, then we can think about data processing. That time we talk about MapReduce. Once we are done with these two, then I can comfortably talk about Pig, Hive, Scoop. Then I can take you to Uzi, Flume, Zookeeper, and I can give you the introduction to Spark, Scala, and then a bit of data analytics. Your entire ecosystem is in your control. Does that make sense, friends? You understand what is our learning path now?
Yes. So Srinivas, just one question.
Please, please.
We are now implementing projects on using Julia. Okay. So I don't know where Julia fits in into this entire Hadoop system. I'm totally new to it. So on your other chart, where does this Julia fit in? Is it over management, above the management tier? Or is it analytics
to
tier?
be honest with you, I'm not sure what exactly is that, Aaron. Let me, is the same?
They say Julia is actually a better processing than Python.
Okay. Is it a framework, something like that?
I think it's a language. It's basically a language.
I got it now. I got it now. Oh, let me just give me 2 minutes. That's fantastic. I tell you now. Yeah, I can tell you now. That fits in as part of your data processing layer. Aaron.
Oh, so it's part of the MapReduce framework.
Exactly. Not part of MapReduce framework. Your MapReduce framework is going to be implemented through, because now MapReduce framework can be implemented using your Java, can be implemented using your Python, now can be implemented using Julia.
Oh, got it. Okay.
So whatever the MapReduce program you're writing, I'll show you now. You have your okay, I'll show you to make you to understand clearly. You can look at this. So you want to process your data. Okay, this is how you process your data by writing a MapReduce job in Java language. Same processing. Now you want to do it in, you can do it in Scala Spark. You can do it in Python. The same logic or the implementation. Now you can start working with Julia. And that's really wonderful. Let me look into this one. I don't know what is the theme behind this one, but I don't think it takes more time for me to understand what this is, but I can help you out in some form. If your need is to write your code in Julia to process your data, I'm not promising you that I can teach you Julia, but I can help you out in getting your things done. Even I can work with you, because I could understand very clearly this is a high level, high performance dynamic programming language for technical computing, especially in the parallel computing requirements or needs. So they have given even few examples here to understand the benchmarks and all. If it is Fortran, if it is Python, if it is different how or the metrics. Okay, so definitely I look at the statistics, it is showing you the decent thing. Maybe in the coming days this is going to be a popular choice for the people to start writing. You see here, does not impose any particular style of parallelism on the user. Instead, it provides number of key building blocks for distributed computation. So the advantage part is instead of you writing, because when you come to Java, in order to write the code, you need to go through a lot of API. So what people are feeling is, in order to write the MapReduce implementation in Java, you need to go through the API and lots and lots of code, becoming painful. Now trying to find out the alternatives, how this can be abstracted. As a part of that only, you have your Scala Spark coming up with the built-in libraries. Of course, top level you may be using it in a simpler way, but ultimately it boils down to the same code. You may not be using it directly, but it gets drilled down to the same thing what you are seeing as part of the MapReduce. Without drilling down to that extent, your code execution will not happen. But to the end user, I mean a programmer like you or me, instead of we taking the pain of spending hours together in writing the MapReduce jobs, we'll be able to write it quickly by using these kind of languages with abstraction on the top of your existing frameworks. Definitely, Arun, we'll look towards that. If possible, we'll work on that. That may be helpful even to others. Let me go through it, and if I feel this is definitely going to be an advantage for us, I don't mind. We'll have a brief discussion on this even within no time.
Okay. Yeah, so the only reason we are using that is, they said Julia is very good for crunching large amount of data like financial data and scientific information.
Okay.
And my company is the biggest warehouse in the United States, data warehousing in the United States. So we are using that for all statistical computing.
Then definitely we need not even do any R&D, because when they have identified this one, definitely, but let us see how we can use that one as part of our activity and see, for data processing in the place of Java, how this can be used to crunch the data and get the meaningful extraction out of it. Let me see. I didn't come across this one anytime, to be honest, but it's not a rocket science to keep it away, right? So we'll definitely work towards that. Arun.
Okay.
Yeah.
Okay.
So you look at this entire stack, you'll be able to understand where we need to start now. Where we need to start. We definitely need to start with data storage. And as part of the data storage, we must start with HDFS only, because even you take HBase, HBase is built on the top of HDFS only. But HBase is specifically for structured storage at Hadoop level, because it is something like Google's big table. Google's big table is replicated in the name of HBase by Apache. What Google is using all these years to store their volumes of data and fetch it very fast. The same is now HBase, not more than that. So we talk about it. But to initiate our discussion, we must start with HDFS. That is the reason why we are here to talk something about distributed file system. So as our end goal is this, our start point is HDFS. That is the reason why we discussed about file system. We discussed about distributed file system. Now we are talking about Hadoop distributed file system. So when I need to talk about Hadoop distributed file system, I need to talk something about Fuse. And if I need to talk something about Fuse, I need to talk something about Linux. And Linux, I need to talk something about operating system. So what is your perspective towards operating system? You are using this one, I think, for the last 2 decades, if I'm not wrong, or at least a decade and a half, or at least a decade. You might be using this some other operating system for the last decade. What is your own perspective towards operating system? Maybe very primitive question, but still I would like to hear from your end. What is your own perspective towards operating system?
It's probably an interface between the user and the hardware.
Yeah, definitely. Definitely. Any other perspective out of your close interaction with the operating system so many years? Any other view towards operating system? No issue, no issue. Like how your planet called Earth is providing you all the things necessary for our life. We are living on this planet called Earth. You require air, you require water, you require shelter, all these things provided by this earth. Same like your operating system is something which provides the environment for your programs to run, right? That is, yeah, definitely. I'm not against your statement. That is where I said your own perspective. Maybe someone else may come out with their own perspective because being a programmer all these years, I'm very biased towards my programs. So it is something which provides me enough resources for my programs to live comfortably. Like how a human being is living comfortably on this planet Earth with the resources provided by this planet. Same like inside the operating system. If I want my program to live comfortably, what it requires? It requires CPU, it requires memory, it requires IO, it requires various things. All these being provided by the operating system to my process. Okay. So one such operating system is Linux. And operating system has got different features. One such feature is it also provides you the file system, which we have already discussed. And this file system is something which is attached to the kernel, the core level. File system is always attached to the kernel. That is where, friends, you see closely, this is where most of the time people are not able to understand. They read the statement, they feel yes, they have understood, they go ahead, but ultimately they are not able to visualize or get that picture in the mind. So I don't want my participants to be like that. For the reason I'm discussing this one so closely. Forget about whether it is slave or master. We talk about later. You look at this one closely. This is what your Linux file system is, or CentOS file system. Instead of saying Linux, I call it as CentOS specifically. The moment you log in, what is the user with which I logged into this box? Root. Yeah, exactly. I logged in as root, right? The moment I log in as root, whatever the space for every user, there is a user called root, there is a user called Srinivas, there is a user called Arun, and there is a user like Sai, like that every user. Because you know very well, Linux is a multi-user, multitasking operating system. I can log in, any number of users can log into that. And every user log in with their credentials will have their own space, will have their own space. That is called user space. Every user is allocated with the space. See, the file system attached at the kernel level is what you are seeing here. The file system attached at the kernel level. At the root level, what we have? At the root level, what we have? We have something called /tmp, /sys, /mnt, /opt, /etc. This is what the file system at the kernel level. But the file system that is given to you here, this is user. You'll be logging in into that one only. And you'll be having bash profile, bash logout, bash history. This is all your user space. Whatever the space that is allocated to that user is called the user space. What you are seeing here, user space. You're getting my point, friends, what I'm sharing here? We have the file system attached at the kernel level, and as part of that file system, for every user, the space is been allocated in the user space, that is under home. Under home, maybe user, the root kind of thing, or maybe under root. I mean, this is the root. For every user, you may have given some space. That is what we call it to be user space. The moment I create a new user, his home is being created, and all the personal settings for that particular user are preserved there. Okay. The beauty part is your Hadoop distributed file system is not set up at the kernel level. If it is being set up at the kernel level, then you will have a lot of challenges, because already on this bare metal box, this is a bare metal box. On this bare metal box, I installed CentOS and I assigned an IP. An IP address is assigned to this. This is the input or the raw material to my cluster. On a bare metal box, I install the CentOS and assign an IP that I can bring into my Hadoop cluster as a host. Okay. When I bring this machine into Hadoop cluster as a host, I need to set up HDFS. If I set up this HDFS at the kernel level, the integrity of this CentOS operating system will get disturbed. Not to happen that one, what I do is, this Hadoop distributed file system is being set up in the user space. This Hadoop distributed file system is being set up in the user space, not at the kernel level. Because of this, what happens? Tomorrow, when I take out, this is a cluster assume, when I take out this particular machine from the cluster, it works as a normal CentOS independent machine. Please try to understand this one, friends. I take out the machine or I take out the host from the Hadoop cluster. It works as an independent normal CentOS box. When I bring a CentOS installed machine into the cluster and deploy the client configuration on that and deploy the or fuse this file system, that is what the term called fuse indicates. Fuse. The term fuse is a very interesting term. Very interesting term, friends. Fuse. Sorry. Fuse is called file system in user space. File system in user space. Your HDFS is going to implement or is going to follow fuse not the kernel level or kernel based or kernel attached or kernel peer file system. See, these are all going to sound very odd to you, friends, but believe me, if you are not able to get that imagination in the mind, what you're trying to achieve, how this HDFS is. I can simply finish this one by discussing HDFS means Hadoop distributed file system. It is one other file system like many other distributed file systems. This is one file system specific to Hadoop. That is why we are calling it as Hadoop distributed file system. My job is on. But you never can get that imagination. And at times when you're going through this technical documentation, you will definitely you'll be confused. I'm going to wiki again. This is the best source all the times. File system in user space. Please follow this one, friends. File system in user space is a software interface for Unix-like computer operating systems that lets non-privileged users create their own file systems without editing kernel code. See how beautifully they developed your HDFS. Oh, sometimes I feel thrilled and sometimes I feel jealous. Oh, how come these people able to develop? I'm able to understand and I'm able to, get into the deeper details, and I feel thrilled looking at all these things, but I feel jealous sometimes why I am not able to get such thoughts. By the time I get the thought, I notice that it is been already implemented somewhere. Sometimes I feel jealous. But anyhow, I'm happy at one thing, that let any new thing comes into the industry, I'm able to quickly grasp that one because of the strong foundation what been laid years back. I want the same thing to happen even with you. See how cleanly you look at this diagram. You look at this diagram at the kernel level. We are going to use the kernel level services, but only through the fuse set up in the user space. A wonderful thing, right? I tell you one classical example. For some reason, you borrowed something from your neighbor. You require something, you borrowed from your neighbor. You bought that one and you kept all your things on the top of that and you used it. Once your usage is over, all those been taken out and that item is been as is given to your neighbor. He's very happy, right? Please, friends, try to understand this scenario. Instead of you changing the shape or changing the color or changing the integrity of the device or equipment that you have taken from your neighbor, you bring that home, use it in such a way on the top of that without disturbing anything, its color, shape, anything. You built something on the top and you used it for 1 day, 2 days, 10 days. You have taken out that one and as is you have returned to your neighbor. Definitely he'll be happy. You don't mind lending you any number of times that one. But you take his item and you paint it with your own color and you change its shape in your own need, and the same you return back. You think he will be happy or she will be happy? Same like here. Please observe this one. Whatever the file system I am forming now, I am forming in the user space, but can deeperly use your kernel features through the file system what I am framing at my user space without modifying or disturbing something at the kernel level. This is achieved by running the file system code in the user space while the fuse module provides only a bridge to the actual kernel interfaces. So I believe you got the understanding, I feel, friends.
So Srinivas, just one question.
Please.
So does it mean all the data, whatever is the data, that all that is stored under that user space and not under the root?
Absolutely. That is what the beauty part here. So when I store it at the user space, I don't require root privileges or I don't require high privileges to get my data stored. That is where they mention it very clearly. Non-privileged users also can create their own file system. So what happens, Arun, here, please look at this one. But you go and see, what is the user now? Arun, what is the user now? The user is HDFS. Look at that one. Root at slave 2. Now it is HDFS at slave 2. So what happens at your HDFS level is, whenever you are trying to set up HDFS on any host, a user by name HDFS will be created. In that HDFS user space only, this HDFS file system is being created. It will not disturb the integrity of your kernel. The moment you take out that system from the cluster, it will work as a normal plain CentOS system. I open one more thing here.
So if I have data in some other user space, but on this node, I just need to give read, write permissions to HDFS for that user space, correct? Is that how it works? If I have data stored in some other user space on this particular server, okay, I have HDFS and I have data, but I wanted to access data from, say, /home/Arun also.
Arun, that question never arises, because all your data at your Hadoop cluster will be stored under the space called HDFS only. So there is no chance, even if it is been stored, say for example, but that is going to be directly or indirectly under HDFS user only.
Oh, got it. Okay.
Because if you look at this ecosystem, you understand that now. Anything that is built on the top is all from HDFS ground up only. You understand the point here?
Yeah, got it.
Wonderful. One second. So you look at this one closely, you really appreciate what is fuse. So I request you friends, because this is not a very big, you see this one here, you don't have much theory to be learned here. You only need to understand these three lines or these three statements, that's it. File system in user space is a software interface. So when I am setting up my Hadoop cluster, what I am doing, tell me? I am creating a fuse. In the user space belong to the user called HDFS. That is what I am trying to show you here in these two things. You see this one? Here, sudo su HDFS. It is saying user HDFS does not exist because this host does not belong to Hadoop cluster, whereas this host belongs to Hadoop cluster. That is why you have a user called HDFS. This is also a CentOS box. This is also a CentOS box. But here, user HDFS does not exist. But here, I didn't create the user. Believe me, friends, I didn't create the user. Who created that one? When I am setting up my HDFS on the node, on the host, when I bring that host into the cluster, I set up HDFS. That time, the user called HDFS is created. In that user space, this HDFS file system is being created. But when I take out that machine out of the Hadoop cluster, it works as a plain normal CentOS box. See how beautiful. I don't know how you are feeling, but I feel thrilled to look at all these. You have integration and at the same time you have isolation. When it is a part of your Hadoop cluster, it is going to work as a machine of your cluster. But when you take out that one from your Hadoop cluster, it works as an independent CentOS box. No change at all because I am not modifying anything at my kernel level. In order to set up, now what is, tell me friends, there is a file system present on the file system now. You have the file system at the kernel level, that is your CentOS file system. On the top of that, in the user space, I am framing one more file system. And this is a file system which can be attached or detached any point of time. How we can attach the file system? By bringing the node into the Hadoop cluster, you can attach the file system. And how you can detach? By taking out, that is what we call it to be commissioning of the node and decommissioning of the node. Commissioning of the node and decommissioning of the node is, let me, we are not going out of the box friends, but you need to bear with me to understand all these things. You have these hosts here. I'll show you. These are the hosts you have. All these are the hosts as part of my cluster. Now I select some host and I say host decommission. Then what is going to happen? I can take this out from, I cannot just plug out the host from the cluster. First I need to decommission. Then I can take out from the cluster. Once I take out from the cluster, it works as a plain normal CentOS box. When I bring the host, how I can bring the host? I can add new host to the cluster. When I am adding the new host to the cluster, I give its IP address and I bring it in and I deploy the client configuration, and during that process HDFS user is created on that machine, and in the user space the file system is being set up, and that will be an integral part of your Hadoop cluster. The storage that is being created there becomes the storage of your cluster.
So this particular thing, you do it on the master or you do it somewhere else?
Which one, Arun? Which one?
The commissioning and decommissioning of nodes.
No, that is the
so
code
that is done on the
management.
master, right?
No, not master. This is separately. This is called Hadoop administration, which I do it. I'll be setting up this Hadoop administration on a separate machine, and through which I'll be managing all my hosts in the cluster. I can bring new hosts. I can decommission. I can commission. I can I make the host to go enter into the maintenance mode. I can do all those things using my Cloudera manager, which is a part of Cloudera, Hadoop administration. Because when you see this one, you have two things actually. One is, as a Hadoop person, you can either, this is called administration, and the other side we have developer role. But as a developer, at least 10 to 20% administration we do. As an admin, at least 10 to 20% development process you should understand. That is how the stage is today. Because there is no clear demarcation between developer and administration roles, because a developer needs to know a bit of administration and administrator knows should know a bit of a development part. That's how we also learn a bit of administration, though we are going to achieve the goal of developer, but we need to know some basics of administration. Some basics of administration. So whatever I'm trying to show you here, this is all a part of administration. And the most interesting thing, I'm equally comfortable. That's what, I don't claim that I know everything, but I'm equally comfortable. Like how I'm a developer, I'm also an admin. I know how to set up from bare metal box to a cluster of 10 node, 20 node, and set up all the services and make them to function properly as expected, and fix any issues in terms of your configuration, or even in terms of health, or even in terms of performance tuning. So we see a bit of administration, and if possible we try to set up a fresh cluster as part of our course sometime so that you understand. But at this stage, to make you to clear, without we setting up HDFS and understanding HDFS, work with HDFS, will not be able to go to the data processing. So to make that a clear visualization for you, I'm trying my best to make you to understand what is this fuse. Your HDFS is a fuse, is a file system in user space. How I can tell you is, let me take you out there. Let me show you that. Um, I'll show you. Your HDFS is basically a file system in the user space, the same. I'll show you here. Um, yes. 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 Look at this one. HDFS can be mounted directly with the file system in user space, virtual file system on Linux and some other Unix systems. See this statement. HDFS can be mounted directly. What do you mean by this? Mounted directly with a file system in user space. So on any host, that is a Linux or Unix host, what can be done is this HDFS can be mounted or unmounted, where not at the kernel level but at the file system in the user space. I mean, I can create a file system in the user space to set up my HDFS. This can be mounted or unmounted without disturbing the integrity of your kernel present on that Linux machine. Are you able to understand my point, friends? That is the reason why it is able to achieve the portability to get deployed on any kind of hardware or any kind of software. You understand what I'm saying? Because this doesn't have any dependency. It can be fused in the user space, it can be mounted in the user space, and it doesn't have any dependency in terms of your software or in terms of your hardware. Because this is a software framework. Fuse is basically a software framework. You can see that one here. Fuse is a software interface. It is not hardware. So this can be set up on your user space without having any dependency on your hardware or your existing operating system. The only thing is you require that fuse library compatible to that particular machine, and you will be able to set up the file system comfortably on it. Yeah, Arun, go ahead. You're trying to ask something.
Yes. So it says it should be Unix or Linux. So which means I cannot set up on a Windows host.
That's a classical question. No. These days it is being made possible by framing a layer on the top of your Windows, like how, see, you can observe this one here. It is being set up in the user space, right? Of course, they mentioned it as Unix or Linux, but if I am able to set up a fuse in the user space of Windows, it is made possible, right? Again, HDFS. Arun, try to get this point.
Okay. Yeah.
If I can
I got
have
it. So you have so there is a fuse for Windows as well. That's what you're saying.
absolutely, you got the point now. There is a fuse for Windows file system even, with which I am able to comfortably set up my Hadoop cluster even on my Windows boxes, which was limited only to Unix boxes in the past. Now it can be on any operating system practically. The only thing is I need to have this fuse where I'm able to set up this file system in the user space, that it is possible to be set up on any box. You won't believe. See, to get this imagination, sometimes I feel, myself, I move into different areas, and I feel, how many things we need to learn. But this, if you take it as a pleasure, you will be definitely enjoying it. Even without understanding all these, you can go to HDFS, run the commands, get your things done. But it is always Greek and Latin for you. But now you look at this diagram, you'll definitely appreciate. This is what the kernel I have, and in the user space, I am trying to set up my fuse. Of course, these libraries are going to internally make use of what they make use. What they make use? They make use of the kernel services, but the file system is now I think you are able to understand, Arun. Arun, please here look at this one. Hadoop fs -ls and /. Now ls-al /. Why these two are different, Arun?
So when you do the LS, it is going at the root level of the CentOS and is listing me all the file systems, whereas Hadoop is going only to the Hadoop user.
Now you got that sense, right? So ls-l is directly going, is a kernel level service, which is giving you the file system present attached to the kernel of that machine only. But now when I use Hadoop FS and I say ls, here also it is ls only, but it is the file system showing in the user space across the cluster. You got the point?
So yeah, so if it is a Windows box and if I have Hadoop installed, do I still use Hadoop LS or do I do a Hadoop directory kind of?
No. Same, because that interface is a generic interface, right? Like how you see a .class file, you run it on a Windows box, a .class file, you run it on Linux box. .class file is the same. But how the dot class file is converted to the Windows understandable, the dot class file is converted into Linux understandable or CentOS understandable. Is been taken care by your JVM. Is been taken care by your fuse. Whatever the command you deploy, how that command needs to take the services from the kernel or what services required from the kernel. Even you take your Windows operating system, there also you'll have a kernel. You may not be using that terminology, but you have the core services running on your, that is what your system. I think you notice when you go to your C drive, you'll be seeing that one right here, program files, all being set up under program files, right? Whenever you set up anything,
Yeah.
even your Windows, here you'll be having something called Windows. I think you notice that one here.
Yeah. Got it. Okay.
Windows NT or all those Windows related things you'll be seeing under this. So there also you'll have, maybe terminology it is different, but it is the same concept that you have. With the help of Fuse, you will be able to achieve that neutrality. So no worries for that. So what I advise you to do is please go through HDFS once, how you can go through HDFS from the original documentation, what I mentioned, whatever best you can. I'm not asking you to go through anything specifically, whatever best documentation you can read out of your comfort. Anyhow, as part of our course, we are going to see HDFS in detail. We work with the commands, we navigate the file system, and we see how these commands are working for you. And we already kept Linux commands that are required for you to work with your HDFS, the basic Linux commands. That document is also being kept in the training block. Please go through that one in the document what I shared. Of course, your practice and all you will not be able to do if you don't have Linux box. Bear with me for one more session. We are going to set up Hadoop on your machines, and then you will be able to comfortably now practice your Linux commands and even your HDFS commands. But by that time, make sure, friends, and bear with me, and this is all for your well-sake. See, I don't have any personal agenda here that I need to teach you all these things if they're not really required. I'm teaching you all these things for the reason, ultimately, even without any machine, you sit under a tree, look into open sky, you should be able to visualize your entire Hadoop cluster. Then only you will be able to do many things in your Hadoop space. That level of imagination you should get, though it is a cluster. I mean, imagining a central system like your laptop is fine, but you should be able to imagine even your Hadoop cluster. You should get that virtual picture or virtualization in the mind. Then only you'll be able to go closer to the technologies and master them within no time. So this is all my effort to make you to understand at that level. Please go through file system in user space, and we don't have much thing. What is Fuse? Fuse, how exactly it works? Maybe bit of R&D you do. You look at this diagram thoroughly, you'll be able to understand and try to apply how this can be incorporated as part of your HDFS. What they might have done to make this Fuse as an integral part of your Hadoop file system. Try to understand that. But we see anyhow as part of our discussion. Will that be fine, friends?